Okay, good evening. Welcome to Mechanical Engineering 303, week 1. So our lecture, as you can see, I think there's something wrong with scheduling. So our lecture is every Tuesdays and Thursdays, and it will be from 7 p.m. to 9 p.m. Okay, so the calendar got it wrong because Tuesday they say 7 to 9, Thursday 7 to 8, which is wrong. Okay. So our lecture from 7 to 8, we have a break, a 5 minutes break. Then we come back, then we go to 9 o'clock. Okay. So let's talk about the course outline. If you were to go to Avenue to Learn, okay, you can see the course outline. So the TA is Player Matthew. This is his email. I only have one TA this term. Textbook is the Beer and Johnson textbook. So what I've done, if I were to go back to the content, and if you all go to welcome module, there is a mechanics of material McGraw-Hill 2012. Please download it, okay? And you will not be able to download by May 7, which is tonight, by midnight, okay? Can you all see this file or no on Avenue? Or maybe I will edit properties. Maybe we will
Yep, it's on
end.
Avenue.
Oh, it's on Avenue. Okay, I'll put on an extra date. Okay, so you have an extra day to download. Okay. Then the next thing, if we go to the course outline again, there's a textbook. This is the schedule. Okay, so today, so week 1, so I detailed them when you will receive your homework. Okay, what content we are going through. So a thing to highlight is June the 6th, okay, it's your term test, and it will be from 7 p.m. to 9 p.m. and it will be held face to face at McMaster University, and I will announce the location at a later date. A thing to take note, week 8, okay, I'm traveling, so week 8, 25th to 27th of June, there's no lecture, okay, so take it as a reading week, okay, take it as a reading week, okay. 11th of July is test 2. I'll test you from homework 4, 5, and 6. Whereas test 1 is 1, 2, and 3. Okay, so test 2 will be on homework 4, 5, and 6. And then on the 8th of August is your final exam. It'll be from homework 3, 4, 5, 6, 7, and 8. Okay, so we'll be tested topics from homework 3 until homework 8, but more emphasis will be from on homework 7 and homework 8. Okay, so this is your schedule. Again, all the testing will be done face to face. Okay, at McMaster Faculty of Engineering, we're not supposed to do any testing or assessment online. The weightage, 10% will be for homework. If you are late, 0.5% will be taken away with or without MSAT. Okay. Term test will be worth 50%. So there's 2 term tests. So for the term test, if you get between 29 to 49 of 100 for the term test, I will schedule a date for you to do a correction test. Okay. So this correction, you do exactly the same question, but to score 100% or to score 50, 50 is the best grade you can get. You have to get your correction everything correct. Okay. So the trick is don't do correction. It's not worth it because correction, you do the question again, everything have to be correct. The best grade you can get is 50%. Okay. Now, if your term test, if the grade is between 2.4, 24.9 or less, no correction will be allowed. Means you did not really study. Okay, so if you're going to do your best, okay, if you are like 30, you can come for correction. If you get 20 of 100, I'll not call you back for correction. Okay, means you really don't understand the content at all, or you did not have the head space. You are too busy to study, basically. Okay, final exam will be worth 40%, or the total will be 100%. Okay, any questions so far regarding the course outline from anyone, please? We're okay, right? So if all of you are okay, so my advice is quickly download the textbook on Avenue to Learn. Okay, that is my only advice. Okay. Okay, so today we are going to talk about buckling. So we are going to go into introduction to buckling. And if you look at the textbook, we are looking at chapter 10. Okay, and chapter 10 is on columns. Okay, I like to start from this chapter, because if I do this chapter last, we will not be able, you will not learn this chapter at all, and which is quite important for your next course, which is called 3E03, which some of you, I think, will be taking it in the fall 2024, okay, next term. Okay, so in buckling, I like to introduce you to an equation which we will use to calculate the critical load. Okay, critical load before buckling will occur. And the formula is PCR, which is the critical load, and is equal to pi squared EI over L squared. And it's so uncommon to see in structure. We have what? We have pi. Can you see we have pi? So it's why is there a pi squared? Okay, so let me define what the terms are. So PCR, as you all know, is the critical load. And then we have E, which is Young's modulus. And then we have I, second moment of area. And then you have L, which is the length of the structure. And if we were to look at units, it can be Newton, or it can be pound force. Young's modulus is in Pascal or PSI, pounds per square inch. Second moment of area, meter to power 4. In PS, in imperial, in inches to power 4. And then the length is in meters or in inches. And if you look at the units, right? So PCR is equal to pi squared. Radians has no units. Young's modulus is in Newton per meter squared. Length or I is meter 4. And then L squared is in meter squared. Okay, so over here the units will be F as Newton, and radians, this is not a unit. Okay, so critical load is in newtons. Okay, so an important thing to take note is buckling only occurs when structure are under compression axial, okay, loading only. So what do I mean by that? Okay, so if I were to draw a transformation, and then this is a beam, okay, so this is our beam, and then I'm going to draw a green line. So our green line oh, sorry. So this green line that you see me drawing, okay, this is our centroid. And buckling will only occur when the load is in compression. Okay, and it only occur when it's compression. So this is P acting along the centroid. Okay, so for this case, we call this, okay, we call this centric loading. Okay, centric loading. Another way that buckling can occur. So for this case, buckling, okay, the load is under compression. Okay, buckling will occur. Then another way or another loading condition which can also induce buckling, it looks like this. Okay, so again, the same structure. And then we have our centroid. However, now the load is different, and I'll show you what is the difference. Now the load is acting this way. P and P prime. Okay. So what is happening now is over here now you have a certain distance, right? You have a certain distance away from the what? Away from the centroid, which I'll call B. And the green line, this is still our centroid. Okay. So for this case, what you see is P is inducing compressive stresses or is inducing compressive load, and the structure is under, okay, eccentric buckling or eccentric loading.